In this APO training video today, we are going to look at supply chain management and where does APO fit in. We are going to look at some components of APO like demand planning, supply network planning, production planning, and detail scheduling. We are going to see how these components interact with the ERP planning systems, and then we will look at the real APO SCM system and see how we actually carry out some of the transactions and use the system. So this is the big picture of SCM or supply chain management. Supply chain management manages the flow of material, information, and capital through a network of suppliers, manufacturers, distributors, and customers. For effective supply chain management, this flow must be well coordinated and integrated within a company and across the company boundaries. So this is the overview of the complete application. On the top you have the planning side of it, which is strategy and planning, and roughly this is what the APO functionality encompasses. So APO stands for Advanced Planning and Optimization, and at the bottom here you have the execution part of supply chain management. The key components of APO is the supply chain design, and then you have the planning strategies. So demand planning, supply network planning, PPDS is production planning, and detailed scheduling. The SAP SCM application can be based on several technical component systems such as the SAP SCM system and the SAP ERP or ECC systems. SAP SCM usually provides the planning functions and the areas of supply chain visibility and supply chain collaboration. SAP ERP, on the other hand, is usually the system in which master data is managed and in which the planning results from SAP SCM are executed. So this is the execution function and this is the planning function. So activities like external procurement, production, sales and shipping, as well as logistics execution happens here. However, non-SAP systems can also be used as execution systems, as you can see in the figure. The system connection of the SAP SCM component is affected by the core interface, and this is a special integration to the ERP system and is available out of the box. And then you have the BAPIs, which are business application programming interfaces, and these help you to integrate SCM with a non-R3 or non-ERP system. The core interface is used to transfer master data and transaction data relevant to planning. From the master data point of view, the core interface is a one-way street from ECC to SCM. The data is transferred within integration models exclusively from the execution system to SAP SCM, where other data relevant to SCM may be added to it. This transfer can be carried out as an initial transfer or an incremental data transfer. Transaction data relevant to planning, on the other hand, is usually exchanged in real time between SCM and the execution system, and that could be ECC or any non-R3 system. When the master data is transferred from ECC to SCM, there is some conversion and renaming. For example, the plant, distribution center, customer, and vendor become locations with the location types plant, distribution center, customer, and vendor. The materials become products. The work centers and capacities become resources. In SCM, you can select various models for planning the production. Now we will have a quick look at the supply chain design within an SCM system and then move on to planning. So this is my SCM system and I do a quick login. Looks just like a standard ERP system, but the menu you will notice is vastly different. So now I want to look at my supply chain model. So advanced planning and optimization, supply chain monitoring, and this is where I can go to the supply chain cockpit and look at my model and various settings around it. The transaction code for going to the model is SAP APO /SCC07, and this takes me directly to my model for pump, and then I display the model. This is what my supply chain model for my pump looks like. Before you can implement and test supply chain scenarios, the first project step is to model the enterprise structure of the precision pump company in this example. This provides the basis for the supply chain definitions. So I can make it bigger and then I switch to an overview. I can move it around the area I want to focus on, make it bigger or smaller. When I move this area, I can choose where I want to focus. So these are the various objects, the plant, for example, planet, addresses, etc. So this is the visual geographic representation of my supply chain. I can also look at the logical view, and my view is a predefined view called pump. So my logical view, and then at the bottom I have these objects that form part of my model. So this is my location tab, and these are all the location objects. In SCM, a location can be a distribution center, manufacturing plant, supplier location, customer, transportation service provider, transportation zone, or even an MRP area. Transportation lanes. These are used for modeling material flow between locations. You use locations and transportation lanes to model your supply chain. Transportation zone, which is part of the location. This can be used to group together customers within a location hierarchy. For example, the transportation zone is used in the transport load builder TLB and in transportation planning. Resources, these can be used to model production capacities, storage capacities, transportation capacities, and handling capabilities. So we can directly jump to the system master data for each of these objects. So for example, I select this vendor 1003 and I right click, and I can see different details here. So if I display a location or a location product, I can directly go to the master data. So here for the vendor, this is my location, this is my location type, which is a vendor, and I see different details here. Similarly, I can do it for other objects. Say a distribution center, right click, display location, and this is my location type, distribution center. Similarly, I can do this for my customer as well. So let me just see, this is my customer, right click, display location, and the location type would be a customer, which it is. Next, we go to the transportation lanes that are valid for a specific product. So these are all the location products that I've got. So let me select a pump, TF201. And now when I right click, I can do a query. So let me just scroll down a little bit so you can see the screen clearly now. So right click, query, and I want to look at the transport net for this product. I click on transport net and I execute. And now if you see, the lanes, the transportation lanes that is valid to transport this product are now colored in red in the graphic. So let me try to make the graphic bigger, and you can see the red lane. So these transport lanes are relevant for TF201 product. So this is how I navigate around my model and help create and fine-tune it. So that was a quick look at the supply chain design and modeling side, and now we'll go to the planning side. This figure gives you a quick overview of the different planning horizons within SCM planning key functional area. So you have demand planning that enables you to predict future sales based on historical data and statistical forecasting techniques. Demand planning data is usually bucketed with no constraints. The forecast data is then released to supply network planning, SNP, to create feasible production and distribution plans. Supply network planning is usually a bucketed and medium-term planning process. Production planning and detailed scheduling is used for short-term order-based planning according to sequences and setup times. In addition, a complete bomb explosion is possible in PPDS. Deployment and transport load builder. These are parts of the SNP module for short-term replenishment planning. They also enable transfers according to short-term changes in demand and supply. Transportation planning optimizes routes and the capacity utilization of means of transport. Demand planning can be executed in either ERP or R3, as it is interchangeably called in this session, or completely in SCM. It creates the input data for either ERP demand management or for supply network planning within SCM itself. A quick comparison between demand planning in ECC and SCM. Basically, we won't go through each of these points, but SCM enables a much better and richer functionality and across the various systems in the organization. ECC is more limited. It's more a legacy kind of planning used for simple plannings with fixed drill downs, simple macros, etc. The demand planning functionality involves using statistical forecasting and advanced macro techniques, And these allow you to create forecasts based on both sales history as well as any number of causal factors, and to use a consensus-based approach to consolidate the results. There are various techniques for creating forecasts for future-based demand. An agreed version is released after the results have been discussed with the various departments. The planned independent requirements that are created from this can be consumed against an incoming customer demand using a variety of strategies. Incoming customer demands are updated in aggregated form and used as a basis for future plans. Consistent planning is used to keep planning data consistent at all planning levels. Data is aggregated and disaggregated automatically. Consistent planning throughout the entire enterprise allows detailed plans to be automatically consolidated. You can decide between different planning methods. You have top-down planning, middle-out planning, bottom-up planning, etc. Consistent planning can be used to simulate several different planning scenarios. The figure here details the different forecasting techniques that may be used. You can also use macros to perform complex calculations quickly and easily. The extreme flexibility of macros allows the planner to model his or her planning environment based on individual business tasks. Let us now have a quick look in the system and see how we work with demand planning. So we go to APO, demand planning, and we will do the interactive demand planning. So I double click on this. The transaction code is STP94 as you saw, and let me select my APO product, planning version 000, and APO product is what I'm going to plan for. So the product I'm going to use is a standard IDIS product TF201, and now I get rid of this section here to make the screen bigger. So I load the data and I see that I've got some data over here, and I need to scroll down and I can see the graphical view of the data that I've got in my plan. So these are my figures on the top, and this is my graphical representation. So if I click here at a point, it gets highlighted. So this is the final forecast. Similarly, it's moved. Again, the final forecast. And I also have my corrected forecast here. And now if I go to interactive planning, univariate forecast, save data, no, because I haven't made any change. I can do a forecasting based on different methods that are available to me. So I will choose a manual model just to keep things clear, and this is my horizon. So this is my forecast horizon from September to December, and this is my history horizon. I'm taking only 3 months history. Parameters, these are the current parameters that I've used to derive this, but if I were to change it to say 22, and then I select this and I execute by pressing this again, and I get the message successfully executed, and you've seen these numbers have changed. Just to try it once more, I will change it to simply 2, Press enter and then press this again, and at the bottom I get the message successfully executed and my numbers have changed again. And you can see when I change it back to, let's say, 7, and then I press execute again, the data changes. I can also look at this table as a graphic view, and the same change in the graph will take place once I change my basic value of the forecast. So using this button, I can bring back my menu on the left. So this is where I can see the macros that are available to me. So I can calculate past forecast, I can copy the data, reset the data, and I've also got some defaults that I may use. So these are the macros we spoke about in the earlier slide that are available to me on this screen as part of demand planning. Supply network planning. Starting from a demand plan, supply network planning determines a feasible short to medium term plan for fulfilling estimated sales quantities. This plan covers both the quantities that must be transported between two locations and the quantities to be produced and procured. When making a recommendation, supply network planning compares all supply chain activities with the available capacity. Supply network planning covers the medium to long-term planning horizon. It creates a quantity-based cross-location production and distribution plan with its own rough-cut bills of material and routings. The data to SNP can come from demand management in ECC or ERP, or it can come from demand planning within SCM itself. The results of SNP can be requirements for stock transfer between plants, stock transport requisitions, they can be planned orders, or they can be purchase requisitions. This is the SNP process flow in a nutshell. Planned independent requirements are generated when the demand plan is released from demand planning. This step is usually carried out in the background. An SNP run uses SNP heuristic, SNP optimization, or capable to match results in a medium-term production and distribution plan. You check the alerts after the SNP run and solve any problems that have occurred. The final SNP plan consists of stock transfers and planned orders. You can automatically convert SNP planned orders into PPDS planned orders within the production horizon. The final SNP plan can also be released back to demand planning so that the unconstrained demand plan can be compared with the feasible SNP plan. After production planning is complete, the deployment run confirms the SNP stock transfers based on current receipts and requirements. And the transport load builder runs groups of deployment stock transfers resulting from the deployment run into TLB shipments. For a deployment stock transfers that could not be satisfied during the TLB run, you can manually build TLB shipments. There are three main planning methods under SNP: the heuristic, optimizer, and CTM. In this session, we won't go through all the three, but we will take a quick look at the heuristic scenario. So this figure here shows the heuristic scenario. 3 steps involved. The first step, there is no demand at a distribution center. The net requirements calculation does not find any stock. The product is procured externally. The system analyzes the possible transportation lanes. Demand is split according to the quota arrangement and distributed to plants by stock transfers. Step 2. There is no stock at the plants, so SNP plans are exploded and the planned orders are created for the finished products and dependent demands are created for the parts. The planned order in the plant with the higher quota arrangement is not feasible from a capacity point of view, so an alert is generated and the supply chain planner must intervene. Step 3. Parts are then procured over the possible transportation lanes according to quota arrangements or priorities. The vendor with the highest priority cannot deliver though. So an alert is generated and the supply chain planner must intervene. Therefore, we see that the heuristic can be used for fast cross-plant distribution and procurement planning if constraints are not usually irrelevant. Here is a quick comparison between the three methods. In terms of performance, the heuristic is the fastest method, the optimizer the slowest and the most complex, and the CTM is in between. However, this is only a general rule of thumb. If you plan a large quantity of orders for each bucket and the location product, the performance of CTM and the optimizer might be comparable since CTM is an order-based planning method. In terms of quality, the heuristics planning results are the weakest, followed by CTM, and the optimizer is expected to provide the best results since the algorithms weigh up all the possible options. Production planning, detailed scheduling, or PP/DS as it is normally called. This is used to plan for critical products such as products with a long replenishment lead time or products to be produced on bottleneck resources. PPDS can reduce lead times, improve on-time delivery performance, increase the throughput of products, and reduce the stock cost through better coordination. You must keep in mind that PPDS is a planning tool. Shop floor control functions such as confirmations must be performed in SAP ECC or in another OLTP system. In demand planning, a sales forecast is created and then transferred to the distribution centers and production plants as planned independent requirements. After SNP has transferred the requirements through stock transfers to the production plants, the production quantities and production capacities must now be planned in the production plant. Production planning is possible in SAP ERP and in SAP SCM. And you see the different scenarios in this figure. Based on the demand program in the producing plant, which consists of planned independent requirements, sales orders, and stock transport requirements, material and capacity plant production and external procurement can be carried out. They can be performed in SAP ERP or in SAP SCM. Production, that is the processing of manufacturing orders, is executed in ERP alone. If you recall, SCM is the planning side of things and ECC is the execution side of things. PPDS is used for short-term order-based planning according to sequences and setup times. In addition, a complete bomb explosion is possible in PPDS. SNP orders have to be converted into PPDS orders to be able to plan the receipts created in SNP. This normally happens before entering the PPDS horizon. The system creates PPDS orders from the SNP orders and deletes the SNP orders. For this conversion, you can choose one of the following. You can carry out a mass conversion of SNP orders that start in the PPDS horizon, or you can convert individual SNP orders specifically within and outside the PPDS horizon. So I hope this brief session gave you a good overview of SCM, APO and the different planning strategies and how we actually carry them out in the system. See you again soon.